Lesson 10, percent increase and decrease. Whoops. All right, so the first thing that we need to cover is our percent increase slash decrease formula. So we're going to use the same formula whether it's a percent increase or a percent decrease. And what that looks like is this. So it is this percent change is equal to your new value minus your original, and that's all being divided by the original amount. So let's practice that. Here it says that a family moves out of a 1,600 square foot home and into a 2,800 square foot home. Part A wants us to create an expression that represents the percent change. So this is part A. Okay, so I have my new minus original. So their new home is 2,800 square feet and their original home is 1,600. And I'm going to divide it by my original value. So this right here is my expression. For part B here is asking us what is the actual percent increase. So this is us just plugging this into a calculator. So let's grab this calculator and I'm going to do 2,800 minus 1,600 all divided by 1,600. Now I get this decimal, this is 0.75. So to change that decimal and to make it a percent, I need to multiply it by 100, which gives me 75. So for this problem, the percent increase is 75%. That's quite a bigger home. Alright, let's try another one. This is that the temperature in Phoenix increases from 80 degrees on a Wednesday to 90 degrees on a Thursday. The percent increase is blank. If the temperature increased by the same percent on Friday, the temperature will be blank. Alright, so for blank 1 here, I need to figure out what the actual percent increase is. So again, we're starting with our new temperature, which is 90. That's what the temperature is Wednesday. The original temperature was 80 degrees, and that's all over 80. So if I type this into our calculator, I have 90 minus 80 over 80, which gives us 0.125. And remember, I need to take that and multiply it by 100 to get our percent, which is going to be 12.5%. So this has a 12.5% increase. And for blank 2, on Thursday it was 90 degrees. So if I take 90 and multiply it by my percentage as a decimal, so 0.125, that's going to give me how many degrees my temperature is increasing by. Then I need to take 90 and add it to however many degrees it increased by to get the new temperature. So let's bring back our calculator, and I'm going to do 90 times 0.125, which tells me it's going to increase by 11.25, so it tells me it's going to be 101.25 degrees. So this is 11.25. I need to add how much my temperature is increasing to what it was the day before. When I add these two together, I get 101.25 degrees. And then don't forget this 12.5% is my increase from blank 1. Alright, here's another question. This is after trading in her old car, Lydia's annual car insurance decreases from 500 to 300. What fraction expression represents the percent decrease? So part A is asking us for a fraction expression for a percent decrease. So it went from 500 to 300, and my original amount is $500. So let's keep this as a fraction because that's what this question is asking for. 500 minus 300 is 200 over 500. Now, these decimals here will cancel. Sorry, not decimals. These zeros will cancel, which leaves us 2 over 5, or we could have 4 over 10. And the reason why I'm putting 4 over 10 here is because when we're working with percents, usually if you have a denominator that's a 10 or a 100, that's easiest because percents are easier to find when you have a 10 or 100 in the denominator, because any number over 100 will give you that percent. So for part B, I want to know what's the percent. If I were to take 4 over 10 and multiply top and bottom by 10, I get 40 over 100. So since my denominator has that 100 in it, that tells me that this is equivalent to 40%. Alright, last example for this type of problem. It says that a book company sells 200 books last week. This week it sold 186. What is the percent decrease? So, for part A, I'm going to set up my 200 minus 186 over 200. Now this is asking me for the percent decrease, so I'm going to pull over my Desmos so I can solve this. So 200 minus 186 over 200. I'm going to take that 0.07 and multiply it by 100 to give me a 7% increase. Okay, so this gave me, this gave me a 0.07. I multiplied it by 100 to get a 7% increase. Part B is asking, what will be the following week's sales if the percent decrease stays the same? So if it was at 186 and it's going to decrease by 0.07, which is the decimal, I'm going to take that number and I'm going to subtract it, because again, we're decreasing, which is why you want to subtract it, okay? So the first thing we got to do is, we got to figure out that number. So let's pull back our calculator and do 186 times 0.07. So it looks like it's going to decrease by around 13 books. Yes, it's not exact 13, but that's safe to say that's pretty close to 13. So it's going to decrease by 13 books, which means 186 minus 13 is going to give us 173. So I can predict that next week's sales will decrease to around 173 books. The last thing I want to talk about is percent error. So this is our percent error formula. Now it has measured value minus actual all divided by actual. So this part right here looks fairly similar to our percent increase and decrease, and then the only thing that's different is it has this plus 100 times 100 at the end. And if you think about it, we kind of did that with some of the other problems. Now this absolute error on top, if you notice, that is just this top portion of our formula. It's just being brought right down here. So the absolute error is telling us how much numerical wise something is off. The percent error tells us the percentage of how much it is off. So we're going to see the difference between both of those right here. So it says that the listed weight of a steel beam is 88 pounds. An engineer weighs the beam and records a weight of 86.5 pounds. The absolute error of the beam is blank 1, and the percent error is blank 2. So blank 1. So remember, this is the absolute value. If I look back at my equation, it's measured value minus actual. So measured value minus actual value. Now the measured value, it says it's supposed to weigh 88 pounds. However, when this engineer weighs it, it's actually only 86.5. So I'm going to subtract 86.5. And this tells me that there's a 1.5 pound absolute error. So there's a 1.5 pound difference between the listed weight versus the actual weight. Now for percent error for blank 2, I'm going to have, again, 88 minus 86.5 in my numerator, oops, point. And this is going to be divided by 86.5 because, again, we're dividing it by our actual value. And I'm going to multiply all of this by 100, which is going to give us the percent error. So we can type all of this into our calculator exactly how we see it here, as long as we're just a little bit careful. So I can do 88 minus, whoops, not divided by, 88 minus 86.5 over 86.5, and I'm going to multiply all of this by 100. And when I do that, I get this long decimal, but let's round it to the nearest tenths. So it looks like this is 1.7. So 1.7%. So it's 1.5 pounds off of the listing, and it's 1.7% off of what it should be. It should be a little bit more than what we got. Alright, so that is all the questions that I have. If you would like to see some more examples or need extra help, please go ahead and give me an email or send me a message. I will be happy to help. Have a wonderful rest of your day.